Hello everyone, welcome back to Study Simplified. So in the today's video, we are going to learn histogram processing part 2, which is histogram matching and also known as histogram specification. So this is an important topic in the digital image processing, especially for the exam and real world application. So in the previous video, we have discussed the histogram equalization, which is automatically improve the image contrast. However, it always produces a uniform histogram and we don't have control over the output. So in this video, we will learn histogram matching, which give us a control enhancement. Okay. So now understand what is histogram matching. So histogram matching is a technique used to transform an image so that its histogram matches a desired or target histogram. In the simple word, we take one image and adjust it so that it looks like another image in terms of intensity distribution. It is also called as histogram specification. So let's understand with the image so that you have a clear idea about it. So here you can see in the image we have an input image and the target histogram. The goal is to modify the input image so that its histogram becomes similar to the target histogram. So the output will be then have similar contrast and appearance as the target one. So I hope this is clear. So now we will understand why we require the histogram matching. Okay. So histogram equalization improve the contrast, but it does not give us a control over the input image should look. Okay. So histogram matching solve this problem by allowing us to define desired histogram, and it is useful when we want consistency across multiple image or when we want a specific visual style. So So the basic concept is very clear. First, we will apply the transformation to the input image. Then we use the target histogram to remap the pixel value. Finally, we will get an output image that closely follows the desired histogram. So essentially, we are mapping intensity from one distribution to another. So we will learn now the steps of histogram matching. So basically, there are four main steps in histogram matching. First, we compute the histogram of the input image. Then second, we will compute the histogram of the target image. Third, we calculate the cumulative distribution function, which is CDF, for both. And finally, we map the intensity value of the input image to the match the target histogram. So let's take an example. So here you have two image which is dull image and well enhanced image. So we want the dull image to look like the enhanced one. So by applying the histogram matching, we can transform the dull image so that it has a similar brightness and the contrast as the enhanced image. So here you can see the clearly difference between the both image. So the original image has low contrast while the match image look clear and more detailed because its histogram is adjusted to match the target input. So we have one other image also. So so here also you can see the difference between the both image. So in the in this one we are using the histogram equalization, and in this we are using the histogram specification. So on the desired area where we want to enhance the quality of the image so that we can enhance that part only so it look more clear. Okay. So this is the basic difference between the histogram equalization and histogram uh, specification. So now let's do a quick comparison between the equalization and matching, or you can say the specification. So equalization produces a uniform histogram and it is simple to apply but lack of control. On the other hand, histogram matching allows us to define the desired output, giving us more control, although it is slightly more complex. Okay, so just I have arranged this all thing in a table form, so you can see the feature and in the equalization and in the matching. So output, you can see the output. It is uniform in the equalization and it is desired output as I want in the matching. Okay. And in the equalization, we don't have control, but in matching, we have control so that we can enhance the image according to us. And complexity. So equalization is very easy and it is very simple, but it is little bit complex to apply. Okay. So this is the difference between the equalization and matching, which is your specification. So now we will see the limitation and application also. Limitation, application, and advantage. Okay. So first we will see the advantage. So here you can see it is a controlled enhancement and it is with better visual consistency and it is useful in the real world application. So this is the advantage of histogram matching, and the next one is the limitation. So there are three limitation in this. So the first one, we require the target output. Okay. So target output means your target histogram and it is slightly complex and not always perfect match. Okay. So suppose this is your original image, original histogram, and this is your target histogram. Okay. So when you will apply uh, this histogram matching, so it may be possible that it won't give you the 100% accuracy. Okay, means as the first one look like it is not it is not it is not match 100% as the target one. Okay, so now talks about the application. So as I have told, histogram matching is a widely used in the real world application. For example, in medical imaging to compare the scan taken as the different time. Okay. So in the satellite image also we can see the application of this to maintain the consistency. So add in a photo editing to apply the filters and presets. Okay. So this is all about the application. So thank you for the watching this video. So in this video, we have learned the histogram matching allows us to control the image enhancement by using a desired histogram. It is more flexible compared to histogram equalization. So in the next video, we will move on the spatial domain filtering, where we will enhance the image using mask and convolution. If you found this helpful, like, share, and subscribe to Study Simplified. See you in the next one. तब तक के लिए keep learning and keep exploring. Bye bye.